So, last YouTube video of the year, and I just want to close off some bits and pieces here. You know, the classes yesterday on Wednesday, I kind of skipped around. The classes did slightly different things. So for period 1, you guys did not do this Eskimo problem. So give this one a try. In period 3, 4, we paused, and I had to let them think about this for a little while before they got there. So I might want to pause, read this, and try to figure out what to do here. The given is that this is a cube. All 3 sides are equal here, length, width, and height. And of course, you got a hemisphere here. The other thing I want you to assume, we're going to make these two. We're going to compare these two potential houses: a prism, a cube house, shaped house, or a hemisphere. You know, a typical igloo. We're not going to put any cubes on the floor. So and same thing over here. Not going to put any cubes on the floor. Not going to build a floor for each one of these. It's just the walls and the roof, so to speak. So give it a try. Good spot to pause. It's going to be a little tricky, I think, to get to the concept of this. An Eskimo has 1,000 square feet of ice blocks. Which shape house would make more sense? And what I really am getting at is, you have the same number of square feet to build these two. In other words, you have the same amount of surface area to build these two. Which one's going to give you more volume? That's what I'm getting after. So from yesterday, we talked about, surface area. If you go start with the prism first, the area of each face, and you don't know the height, the length, the width, you don't know anything, so you just got to call them x. This is x by x. Uh-oh, don't want that. No. Sorry about that. The front is x by x, the left is x by x, the right's x by x, the top's x by x. So each face is x by x, or x squared, in terms of its area. Think about it for a second. How many of these surfaces are there? Well, of course, there's 5 of them. So the area, surface area of this entire thing is 5x squared. And the given in the problem was that you had 1,000 square feet of blocks to build with. So you can pretty easily solve that. Then you can divide by 5. Take the square root of 200 and you get around 14.1. Try that on your own, see if that makes sense. So that would be the height of this little house. It'd be the length, the width, it'd be all the dimensions for this. Try the same exact thing with the hemisphere. And I had a lot of people in the class try to say, well, if it's 14.1 here, I'm going to use 14.1 for my radius. And some people said, no, I'm going to use 14.1 for the diameter. None of those is true. This is not the thing that's the same. It's the square footage that's the same. It's the surface area that's the same. You have a number of blocks to build this curved structure on here. And we're going to try to compare the volumes. Now, you certainly could go and find the volume right now if you want to do that. Think about how you find the volume of a cube. It's pretty easy. You find the base area times the height. And in this case, it's 14.1 times 14.1. And the height is also 14.1. So 14.1 cubed. I don't want to get to that right now. I'm going to compare that at the end. So we talked about the surface area of a sphere being 4 pi r squared. Well, if it's a hemisphere, it's half of that, or 2 pi r squared. And again, we're not considering the base. If we consider the base on there, it would be another pi r squared or 3 pi r squared. So we plug in S. It's given there's 1,000 square feet of blocks. Simplify that to 2 pi r squared, and then solve for the radius to figure out how big this actual house is going to be. Figure out the height of the house, in other words. So of course you divide by 2, you get 500. You divide by pi, you get some decimal, and then you take the square root, and I believe it's 12.6. Now, looking at these, you'd say, well, this is a taller house, and this is a shorter house. Maybe this one's going to be bigger. The idea is, I'm put it up here, I want you to compare the volumes now. You have this same amount of material to build with. Which is going to give you more volume? Some of you will go, well, maybe this is because it's circular, it's going to waste less space, which is 100% true. So you got to remember how to find volume. And like we said, this is just 14.1 cubed. That's an easy one. I think you get around 2,828. Check me on that for the volume of the prism. And then over here, to find the volume of a hemisphere, it's that 4/3 pi r cubed, but you only want to take half of that. So 4/3 pi r cubed for the volume, divided by 2 at the end. Or you could do 2/3 pi r cubed. Some people did that. You see you get a much larger volume for the hemisphere. Much larger. So I'm going to jump to, that's why people love igloos, I guess. The old McDonald problem, one class didn't do it. If you need to fast forward, if you're in period 1, you want to fast forward. If you're in period 2, you want to try this one. So you got a silo we're trying to fill up here. Silo is 12 feet in diameter, and 25 feet high. Now 25 feet does not get you to the top of the silo. It gets you to the top of the cylindrical part of the silo. Think about the height of this little section here. And remember, if the diameter is 12 down here, then the height of this thing would be 6 because the radius is 6 here, whether it's going sideways or going vertical. So if you were at the top of that, you'd actually be 31 feet off the ground. So the cylinder part's 25 feet high and 12 feet wide, or 12 feet in diameter. So 2 questions. How much corn can you fit in the silo? And of course that's asking you to find volume because it's, you know, space inside something. And it's corn as a quantity of cubic feet in this case. So of course it makes sense that you take the volume of the hemisphere and add it to the volume of the cylinder and add those two together. So you look up very quickly your volumes for cylinder and hemisphere. I would pause right now and try to do it on your own if I were you. Volume of a cylinder is base area times the height. Of course, the base area is a circle, so that's pi r squared times the height. And the volume of a hemisphere is that 4/3 pi r cubed. We want to take half of that. So you could do like 2 pi r cubed and divide by 3 if you want. Or you could just do that part of the equation and then divide it by 2 at the end. Either way works. Like I said, good time to pause. You should end up with around 3,280 cubic feet of corn. And that's as if this thing's filled all the way up to the top of the silo. First period had a good argument about how the heck silos work, and obviously I don't know anything about that, so I'm going to stop talking about it. I told him I'm going to fill it with popcorn. That's how I'm going to fill it to the top. Second question on here is, if one can of paint covers 100 square feet, how many cans would I need to cover the entire silo? So think about all the surfaces you'd need to cover. And I want to paint the entire silo. And of course that would be the lateral area of a cylinder, the rectangle that's rolled up basically to make that silo, and the surface area of the hemisphere, not including the circles that sort of adjoin to each other at the top of the silo. So of course you know that the lateral area is the circumference times the height, and the area of a hemisphere is half of the sphere formula, so half of 4 pi r squared, which again is 2 pi r squared. And I think if you plug some numbers in, you get 300 pi, and you get 72 pi, or 372 pi. If you multiply that out, you get 1,169 square feet approximately. So that's the amount of paint that we have to cover. Now, if each paint can covers 100 square feet, you divide that by 100, and you'd have to round it up because you're not going to, you don't want to come up just barely short. You want to get the thing covered so you get a little extra paint. So 11.69 cans, or 12 is what you'll probably buy. The tent problem, I'm just going to put some dimensions up here and let you start this one on your own. One class already did it, so if you're period 1, you can skip this one. If you're period 2, I encourage you to try it. It is a triangular prism. See if you can find the tent's capacity. You have to know what that word means. And find the amount of canvas, or the cost of the canvas, if it costs 6 cents per square foot.